Algebra 1 students. Today we're reviewing topic 8, quadratic functions, and you should follow along on the handout. For the vocabulary review, it's saying that the graph of a quadratic function is a parabola. The function x squared is called the quadratic parent function. To model the height of an object launched into air t seconds after it is launched, you can use the vertical motion model. The blank is f of x equals ax squared plus bx plus c, and that is the standard form of a quadratic function. And it's good for you to write rather than drawing arrows because it'll help it stick in your mind better. And then the last one, a blank is a method used to find a quadratic function that best fits a data set. And we skipped this part, or we skipped this section, but it would be a quadratic regression. If you wanted to study that on your own, you could Google it, quadratic regression. And that helps you find, like when we did the line of best fit, you can do the quadratic regression for a parabola. Sorry about that. All right, for section 8.1, we talked about parabolas. We talked about the vertex being at 0, 0 if it's this function, and the axis of symmetry being x equals 0. We also talked about when a is positive, it opens upward. And when a is negative, it opens downward. And when it opens upward, there's a minimum, and when it opens downward, there is a maximum. And there's a picture of this showing g of x is negative, and so it's opening downward. And it's wide because the a is less than 1, so it's opening very widely. And then if the a is greater than 1, it opens up narrow. So this one is opening upward and it's more narrow because the a is just 1. And if it was 2, if a was 2, it would be even more narrow like that. Okay, so let's use that example we just talked about to compare this function, g of x equals 1.5 x squared, to the parent function just x squared. So the 1.5 means that it's going to open upward because a is greater than 0. So it opens upward. And the a is also greater than 1, so it will be more narrow. A is greater than 1, so narrow. And then for number 8, the a is less than 0, so it opens downward. And the absolute value of a, this should be absolute value, is greater than 1, so it's very narrow compared to the parent function. So like if this is the parent function, x squared, then negative 9x squared would be very narrow, like this. And then the 1.5x squared would just kind of be a little bit more narrow. In section 8-2, we covered quadratic functions in vertex form. So this is the vertex form. And remember that HK is the axis of is the vertex, and the axis of symmetry is x equals h. And then there's an example, and they ask you to graph it. And so the vertex is at -1, -1, because remember this is opposite of what we think it would be. If it's in the parentheses, it's opposite. Outside of the parentheses, it's just as it is. So this is our vertex, and then from that point we go up 1/1 to find these points, and then we can go, let's see, from there, yeah. And then it looks like they went over 1 from there and up 3 to get those points. All right. So how would we apply this? In these questions, number 12, it says, identify the vertex and the axis of symmetry of the graph of each function. So we're going to use this 8 and this 1. Remember the 8 inside the parentheses is opposite, so it will be -8, comma, +1 because it's on the outside and it's positive. And then x equals the x value, which is -8. So that's the axis of symmetry. So this was our vertex, and this was our axis of symmetry. Okay, on number 13, we have -5 and -2. The -5 becomes positive, and the -2 stays negative. That's our vertex. And then our axis of symmetry is x equals 5. An astronaut on the moon throws a moon rock into the air. The rock's height in meters above the moon's surface x seconds after it is thrown can be determined by the function h of x equals -1.6, comma, or parentheses x minus 2.5 squared plus 15. They're asking what is the maximum height and how many seconds after being thrown does it reach that height? This is simply a vertex question, and so looking at these two numbers, we can figure out the vertex. -2.5, comma, oh, I'm sorry, it's not negative, it's because it's opposite. So 2.5, comma, 15. And this refers to seconds, and this refers to meters. So it reaches its maximum height after 2.5 seconds, and the maximum height is 15. So that's max height. And when you're ready, turn the page. When we studied 8-3, we studied quadratic functions in standard form. And the standard form is this: f of x equals ax squared plus bx plus c. And in this case, a does not equal 0. The y-intercept is c. And the axis of symmetry, which is also the x-coordinate of the vertex, is x equals -b/2a. In this example that we're given, we're asked to graph the function 3x squared minus 6x plus 2. And then first they find the axis of symmetry, which is -b/2a, which comes from here. That's your b, and that's your a. And you'll need to notice that they put the negative here and here. So it ends up canceling 6/6, and the negatives cancel, equals 1. Then you plug that in to find the y-coordinate of the vertex. So this is the axis of symmetry. And then when you plug in 1, which was what x equaled, you get -1. So that's your vertex on the axis of symmetry and at -1. Then you need to find the y-intercept. And so the vertex is here. The y-intercept was 0, 2 right here. And then you reflect it over to get this, and you can graph your parabola. Okay, so let's apply it. Identify the y-intercept, the axis of symmetry, and the vertex of the graph. Okay, so the y-intercept, and I left a lot of space here so that we can graph it. The y-intercept is right here. So it's 0, 5. The axis of symmetry is x equals -b over 2a. Negative b over 2 times -1, because this is your a and this is your b. And when we simplify that, we get 4, -4 over -2, which is just 2. So x equals 2 for our axis of symmetry. And then we need to plug that in. I'm going to bring this down though, because we still have to work on number 16 after this. When we plug that into the function, g of 2 equals -2 squared plus 4 times 2 plus 5. That's just from this equation. When we simplify it, we get 2 squared is 4, so -4 plus 4 times 2 is 8 plus 5. 13 minus 4 is 9. So our vertex is 2, 9, because we plugged in 2 and we got 9. And now we can graph that using these points and this axis of symmetry. So we'll do a little graph. I'm going up to 9, and my axis of symmetry is here at 2. And then our y-intercept is 0, 5. And then we'll reflect that point over. And 2, 9 is right here. We knew it opened it downward because it was a -a. Okay, so this is the vertex, and the y-intercept was 0, 5. And then we just mirrored this point over the axis of symmetry, which would be 4, 5. Okay, let's apply the same method to number 16. The y-intercept is your c, which is this, so 0, 1. Your axis of symmetry is -b over 2a. Oops, it should be a. So -b is 7. 2 times a is -3. The negatives cancel, so we get 7 over 6. And then we plug 7 over 6 into the equation. So we're going to put h, 7 over 6 is equal to -3, 7 over 6 squared, plus 7 parentheses 7 over 6 plus 1. Okay, 7 over 6 squared is 49 over 36 times negative 3 plus 7 times 7 over 6 is 49 over 6 plus 1. And I think I'm going to want to cross cancel here. So this and this become 1 and 12. And that is equal to 49 twelfths, which I'm just going to leave like that, plus 49 over 6 I could make into over 12 by multiplying by 2. And that would be 98 plus 1, which I'm going to write as 12 over 12. And let's see what we get. So 98 plus 49 is 147 plus 12 is 159 twelfths. We're kind of running out of space here, and I don't really want to graph fractions anyway, but we would have as our vertex, if we plugged in 7, 6, we would get 159 twelfths. And you would probably want to put those into decimals if you're going to try to graph them. All right, so if you were going to graph this, you would have an axis of symmetry of 7 6, a y-intercept of 0, 1, and then this would be your vertex. For section 8-4, we learned modeling with quadratic functions. And we used the vertical motion model, which is like right here, and they plugged in 64 for V0, and they plugged in 6 for the height. And it's talking about Alberto launching an emergency flare at an initial velocity of 64 feet per second from an initial height of 6 feet. The flare must reach a height of 100 feet to be seen by a rescue team. Is Alberto's launch successful? I hope so. But unfortunately, when they plugged in 64 for B and they plugged in negative 16 for A, they got 2, right, like right here, negative B over 2A. And then when they plugged in 64 for the B and negative 16 for the A, timesing it by 2, it reduces to just 2. And when you plugged in 2 to the equation and work it all out, they only got 70, so the maximum height is only 70. So it would not be successful. Well, that's a sad story, a sad problem. Okay, so let's practice this. Write a function h to model the vertical motion for each situation given h of t equals negative gt squared, or negative 16t squared plus v0, initial velocity, times t time, plus h, height, initial height. So we're just using that formula. H of t equals negative 16, and instead of t, we're going to put, oh no, we leave t, I'm sorry. Negative 16t squared, because that's our variable t for time, plus the initial velocity, which is 54, and then we need the variable t with that one, plus the initial height, and there is no variable t with the initial height. And then for number 21, h of t equals negative 16t squared plus the initial velocity, which in this case is 18t, plus the initial height, which is 9. And that completes our topic 8 review. Please study this, read it over tonight, because tomorrow we are going to have our topic 8 test, and it will be 10 questions similar to the ones we did in this review.